In this video, you will learn about scientific notation. So the first question is, what is scientific notation? Well, scientific notation is simply a shorthand way of writing a very large or a very small number. So like in science, if you have a really large distance between maybe two planets or something else in outer space, you want a quick way to express that very large number. Or in chemistry, say you're dealing with very small atoms or whatever, you would want a quicker way or a better way to write those really small numbers. So there's a process that we have to write something in scientific notation. The process is as follows. You begin by moving the decimal after the first non-zero number. And then from there, you're going to multiply that new number by 10 to some power. And the power you're going to raise it to depends on the number of places the decimal was moved. So for example, here we have the number 230 million. So it's not a very large number, but this is good to illustrate how to write in scientific notation. What you want to do is you move the decimal from the end of the number to after the first non-zero number. So the first number that's not zero is 2. So move the decimal after the 2. So that becomes 2.3. And then times 10 to some power. The power we raise this to depends on how far we move the decimal place. So the decimal started here. We moved it over 1, 2, 3, 4, 5, 6, 7, 8 places. So we moved it 8 places, therefore the exponent would be 8. Okay, next we have 42,500. So to write this, I move the decimal after the first non-zero number. So the first number that's not 0 is 4. So move it after the 4. This becomes 4.25 times 10 to some power. That power is determined based off the number of places the decimal moved. So it started here, and it's going over 1, 2, 3, 4 places, so therefore the exponent is 4. Now the question is, what do you do if it's a small number? So if it's smaller than 1, what do you do? Well, it's still the same exact process. The only difference will be with the exponent. So the decimal moves after the first non-zero number. So these are all zeros. The first number that's not 0 is the 2. So the decimal moves after the 2. So this becomes 2.3 times 10 to some power. Well, it's moving from here over 1, 2, 3 places. So the exponent must be a 3. Now it's going to be a negative 3 because this number is smaller than 1. 0.0023 is much smaller than 1, so therefore this would be a negative exponent. Because as we discussed in our lesson on exponents, the negative exponent simply means a fraction. That means 1 over 10 to the third power. So it's a fraction, meaning it's going to be smaller than 1. So that's why it's the negative exponent. Next we have this expression. So the decimal is moving after the 4, the first non-zero number. So it's moving from here over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So this becomes 4.6 times 10 to the negative 11th power because it's moving 11 places. And it's negative because this number is much smaller than 1. So those last examples were showing how to convert from decimal form into scientific notation. The next few examples will show you how to go back from scientific notation into decimal form. So here we have example 1, where you have 6.534 times 10 to the 4th power. So here we're multiplying by 10 to the fourth power, meaning this number is going to be a big number, right? 10 to the fourth power is a 1 with 4 zeros. So 10 times 10 times 10 times 10. That's multiplying by a 1 with 4 zeros, 2, 3, 4. So if you multiply this 6.534 times 10,000, this number clearly is going to be bigger than 6. Okay? So what I'm doing is I'm making this number bigger by moving the decimal place 4 places. So to make it bigger, it needs to go to the right. So it goes over to the right 4 places. So it goes 1, 2, 3, and then one more is 4. You need to add a 0. So that's going to give me 65,340. Here we have 7.1 times 10 to the third power. 10 to the third is definitely bigger than 1. That's going to be a 1 with 3 zeros. So you're multiplying by a 1 with 3 zeros, which means you're multiplying by 1,000. So the final answer is going to be clearly bigger than 7, than the original number. So to make it bigger, I need to move the decimal place to the right. So I move it to the right 3 places because we have 3 zeros. So 3 places would take me over 1, and then we need 2 more after that. So 2 zeros after the 1. So my answer would be 7,100. Number 3, we have 1.23 times 10 to the negative third power. So you're multiplying by 10 to the negative third, which is the same thing as 1 over 10 to the positive third, which is going to be 1 over a 1 with 3 zeros. So you're multiplying 1.23 times this fraction. So that means my number is going to be getting smaller. So to make the number smaller, I need to move the decimal place to the left. And the distance is going to be 3 because the exponent here with the 10 is a 3. So move the decimal 3 places to the left. So over 1, and then 2 more after that would give me 2 zeros in the front. 1, 2. So my answer would be 0.00123. Example 4. We have 5.2 times 10 to the negative fourth power. So once again, 10 to the negative fourth is going to be a fraction. It's going to be 1 over 10 to the positive fourth, or a 1 over 1 with 4 zeros. So my answer is getting smaller because we're multiplying by a fraction. So to make the 5.2 smaller, I move the decimal to the left side. I'm moving it 4 places because of the 4 in the exponent. So moving it 1 takes me here, and we need to move it 3 more after that. So 3 more places means we have to add 3 zeros in the front. So my answer is going to be 0.00052. So now that we can know how to convert back and forth, we need to know how to do operations with scientific notation. So how do you multiply and how do you divide with scientific notation? So here's an example where we are, dividing scientific notation. We have 2.4 times 10 to the 6 divided by 2.0 times 10 squared. All I do to divide is I simply separate the fraction. So we look at the number components, the 2.4 divided by 2.0, and then we look at the part with the exponents separately. So if I do 2.4 divided by 2.0, I can do this by hand or on a calculator. Do it by hand, a little review on division. You want to begin by moving the decimal over 1 place. So we're going to have 24 divided by 20. So I see how many times is 20 going to 24. That's 1. Then I multiply 1 times 20 to get 20. Subtract, I have 4. I now can put a decimal here, put a 0 here, and then drop the 0. And then I repeat and do this one more time. So how many times is 20 going to 40? That is 2, because 2 times 20 is 40. Subtract, the remainder is 0. and the decimal goes right here. So it's going to be 1.2. So this part right here is 1.2. And then here, the 10 to the 6th divided by 10 squared, I'm dividing, so I subtract the exponents. 6 minus 2 gives me 10 to the 4th power. So my solution is 1.2 times 10 to the 4th power. Now for example 6. Same idea, 3.2 times 10 to the 4th divided by 2.8 times 10 to the 7th power. So to begin, I'm going to separate this into two separate fractions, where I have the 3.2 divided by 2.8 by itself, and then 10 to the 4th divided by 10 to the 7th by itself over here. If I do 3.2 divided by 2.8, I like to begin by moving the decimal over on the top and the bottom. And by the way, I can do that because what I'm doing is I'm multiplying the top and the bottom by 10. So multiplying by 10 over 10, which is multiplying by 1, which doesn't change my original number. It's just changing the way it looks. So the top is 32. The bottom becomes 28. So when I divide 32 by 28, I see how many times does 28 go into 32. It's going to be 1. 1 times 28 is 28. Subtract, it's 4. Decimal, put a 0. Bring down. 28 goes into 40 one time. So 1 times 28 is 28. Subtract again, that's 12. Another 0, bring down. 28 goes into 120. That would be 4 times. So 4 goes here. 4 times 28 would be 32, carry the 3, that's 111. And the remainder is going to be an 8. So the remainder is 8. We could keep going. 8 over 28 is going to be smaller than 1/2. So when you round this, it's going to be 1.14. So round this to 1.14 for this left side. And then the right side, 10 to the 4th divided by 10 to the 7th. You subtract the exponents. So we have 4 minus 7. That gives me -3. So my answer, when you round this 1.14, it's going to be 1.14 times 10 to the -3rd power. And then when you multiply, it's the same thing. So here we have a multiplication problem. What you want to do is you want to compare or look at the number part by itself, and then you're going to look at the ones with the exponent by itself as well. So I can do this as 2.2 times 5, and then over here we have 10 to the 4th times 10 to the 3rd. Well, 2.2 times 5, if you do that correctly, you would get 11. So this is 11, or 11.0, same thing. And then here, 10 to the 4th times 10 cubed, you're multiplying, so you add the exponents. 4 plus 3 gives me 7. So I have 11, or 11.0, times 10 to the 7th power. This is not quite in scientific notation because the decimal needs to be over after this first non-zero number. So the 11.0, I can write that as 1.1. I move it over here after the 1. 1.1 times 10 to some power. Well, it's moving over one place, so it's 10 to the 1st power. So this would be 1.1 times 10 to the 1st power, and then you have the times 10 to the 7th power. Well, 10 to the 1st times 10 to the 7th, you can add the 1 plus 7 to get 8. So this would be 10 to the 8th power over here, 1.1 over there. So my answer is 1.1 times 10 to the 8th power. So in this lesson, you've learned how to write in scientific notation, how to convert out of scientific notation back into decimal form, and you've learned how to multiply and divide with scientific notation. And that concludes our lesson for today.